Hello, everybody, and welcome back to Unit 1 of Regents Chemistry, which is Math of Chemistry. Today, we will continue our discussion on scientific notation, and we will be focusing on how we can perform different calculations like addition, subtraction, multiplication, and division with scientific notations. So let's start with multiplication and division. Let's say you have to multiply two numbers that are given in scientific notation. Something like this. First thing that you do is you can just go ahead and multiply their coefficients. So remember, coefficients are these numbers like 2.0 and 3.0. These are your coefficients. So first you go ahead and multiply those. And then for the exponents, you can just go ahead and add them. So in this case, we'll add 3 and 4. So our answer will be 2.0 plus 3.0, which will be 6.0, and then the exponent will be 3 plus 4, which will be 7. So this is what the answer is going to look like. If we are dividing two numbers given in scientific notation, something like this, then first of all, as always, and by the way, this slash sign just represents division. If you ever see that sign anywhere, that represents division. Unless you are in an English class, that's when it represents or sometimes. Okay, so first of all, we can just go ahead and divide the coefficients. So like in this case, 10.0 divided by 5.0, so that would be 2.0. And then for the exponents, we can go ahead and subtract them. So that would be 5 minus 2, which gives us 3. So our answer will be 2.0 times 10 to the power of 3. So let's quickly look at how can we do addition and subtraction using scientific notations. So the first thing that you'll have to do is you'll have to shift your decimal and you'll have to adjust your exponent so that both of your exponents for both of the numbers or all three of the numbers, if let's say you have more than two, which sometimes happens in case of addition, um, you want to make sure that all of your numbers have the same exponent. So for example, if you look at this example right here, you see both of them have different exponents. The first one has an exponent of 2, the second has an exponent of 3. So what we want to do here is we want to make sure that both of them have the same number. So it can either be, we can make both of them 2, or we can make both of them 3. So let's say I decide to make both of them 3. So I'll have to change this first 2 into a 3. So remember this rule that we discussed last time, that when we are moving the decimal to the right, exponent decreases, moving the decimal to the left, exponent increases. So in this case, as we have to, when I want to make this 2 a 3, I am basically trying to increase the exponent. So this is the rule that we'll be using, and we will have to move our decimal one time to the right. Why? Because the difference between 2 and 3 is only 1. So we'll move our decimal one time to the left. So that is going to give us 4.55 times 10 to the power of 3. And then the second number is going to remain the same. We'll just, now we can just go ahead and add our coefficients. Add or subtract whatever the question is saying. And then in this case, 4.55 plus 2.5. And then we will keep our exponent because it is the same for both of them. So that would be 7.05 times 10 to the power of 3. So let's look at some examples. Here we have a multiplication problem. As we said, whenever we have two scientific notations that are multiplying with each other, first thing that we do is we multiply the coefficient. So 6.50 times 5.0 gives us 32.5. And then we just add the exponent. So 4 plus 6 gives us times 10 to the power of 10. Okay? Here we have a question where we have two scientific notations dividing. First thing that we do is divide the exponents. So 2.3 divided by 4.0, that gives us 0.575. Then we want to go ahead and add the exponents, subtract the exponents because this is division. So 3 minus 4 gives us an exponent of -1. So that's what the answer will be, times 10 to the power of -1. Here we have a subtraction problem. 7.9 times 10 to the power of 3 minus 0.04 times 10 to the power of 5. Once again, first thing that we want to do here is we want to make sure both of them have the same exponent. So we can either make both of them 3 or we can make both of them a 5. Okay, so remember our rule. When we move the decimal to the right, exponent decreases. When we move the decimal to the left, exponent increases. So let's say in this case, I want to increase my 3 to a 5. Okay, so this is the rule that I'll be using. I have to move my decimal 2 times to the left. Why 2 times? Because the difference between 3 and 5 is 2. So there you go. I will go ahead and move my decimal 2 times to the left, and that number will now become 0.079, because remember, when we move the decimal, we also have to add a 0. So there we have that number, and we already have our previous number. So now we can just go ahead and do the subtraction. So 0.079 minus 0.04, and that gives us 0.039. And then our exponent is the same, so that is what is going to stay with our answer. Lastly, we have an example of an addition problem. Two scientific notations adding together. Once again, we want to make sure that both of them have the same exponent. So we can either make both of them -4 or we can make them -6. So remember our rule, decimal moving to the right, exponent decreases, and decimal moving to the left, exponent increases. So in this case, let's say I want to increase my -6 to a -4, because remember, these are negative numbers, so -6 is actually smaller than -4. So I want to increase my -6 to -4. That means I will have to move my decimal 2 times to the left. Why 2 times? Once again, the difference between -3 and -4 is 2. So here I will be moving my decimal 2 times to the left. It becomes 0.049 times 10 to the power of times 10 to the power of -4. Now we can just go ahead and do our addition. So 9.2 plus 0.049. That gives us 9.249. And then because now we have the same exponent, that's what our answer will carry, times 10 to the power of -4. Alrighty, so that was it for how can we perform calculations using scientific notations. Happy learning. I will see you guys in the next part of this chapter.